Let's discuss this question next. The question says that determine n if 2nc3 is to nc3, the ratio is equal to 12:1. Okay, if this is the case, then let us apply this idea. 2nc3 over nc3 is equal to 12/1. This implies what? Now 2nc3, what is 2nc3 equal to? This is equal to 2n factorial, okay, over 3 factorial 2n minus 3 factorial times denominator has nc3, which will be actually n factorial, and here you'll have 3 factorial, here you'll have n minus 3 factorial. Is that okay? Yes. And this ratio is equal to 12/1. This ratio is equal to 12/1. Now let's see where does that take us. So 3 factorial goes with 3 factorial, this gets cancelled, and 2n factorial, 2n minus 3 factorial. There are a few extra terms over here. What are those? 2n minus 1, 2n minus 2, and next term would be 2n minus 3 factorial, which gets cancelled with this 2n minus 3 factorial. What about this term? N factorial and n minus 3 factorial. N factorial is greater, so n, this term will be there, n minus 1 will be there, n minus 2 will be there, and after that n minus 3 factorial will get cancelled with this one. And this here is equal to 12/1. Let's see, this n goes with this n, okay, and what else? This 2 cancels this 12, there will be a 6 over here. Now let's observe, this is the product which we have in the LHS, and this will go in the RHS. This becomes 4n square, 2n into 2n is 4n square, minus 4n minus 2n will become minus 6n, and plus 2 is equal to, what do we have? 6 times you have n square minus 3n plus 2 in the RHS. Do you observe that? Yes. Please observe, there's a factor of 2 coming out common from here. Yes, we can cancel that factor, and what will remain is 2n square minus 3n plus 1, which is equal to what? The factor of 2 gets cancelled with this 6. What remains here is 3. 3 times n square minus 9n plus 6 is what I get. Okay, let's create the quadratic. Let's see what's the quadratic that we are getting. This gives me n square, okay, minus 6n, okay, plus 5 is what I get. And from here I can observe that n equals 1 or n equals 5. Now you can clearly observe one thing. What do we observe? That for defining NC3, n should be at least 3. So n equals to 1 is not okay. This is rejected. N equals 5 is accepted, as you can see over there. So n equals to 5 is my correct answer for this question over here. Let's talk about the next question. This says determine n if 2nc3 is to nc3 is equal to 11:1. Okay, what happens in this case? Let's solve this question. This is 2nc3 over nc3, which is equal to 11/1. Okay, we just solved 2nc3 upon nc3 in the previous part of the same question, and what did we get over there? This is 2n minus 1, 2n minus, sorry, there was a 2n as well. Don't forget that 2n. Things begin with 2n, right? So let's begin with that 2n, 2n minus 1, 2n minus 2. Okay, and you'll have 3 to 1 in the denominator of this. Similarly, for nc3, you'll have n minus 1, n minus 2. Right? You can go a step back and see the solution of the first part, in which we have calculated this LHS to be equal to this. This is equal to 11/1. Is that okay? Yes. This n goes with this n. Okay. And what do we get in the numerator? In the numerator, you get a lot of things. This is 2n times 2n. 2 is outside. This is 4n square minus 6n plus 2 in the LHS. In the RHS, you have 11 times this factor, which is n square minus 3n plus 2. Right? This is what you have. Let's multiply and create a quadratic. This is 8n square minus 12n plus 4 is equal to 11n square minus 33n plus 22. This is what you have, right? And after this, let's take everything on the right hand side. This becomes 3n square, 12n minus 33n. What will that be? Minus 21n, and 22 minus 4 is plus 18 equals 0. This is what I get. Dividing by 3, we get n square minus 7n plus 6 equals 0, and this gives me n equals 1 or n equals 6. right? Factoring the middle term, right? As 6 and 1, this will give me n equals 1 and remember the previous question also we rejected this n equal to 1 because n should be at least 3, right? For defining NC3, n should be at least 3. So therefore the correct answer for this question is n equals 6. That's the correct answer for this question over here.